Okay, let's figure out what the hybridization for each of the carbon atoms and the molecules are, as well as determine the sigma pi bonds. All right, so let's do A first. That's methane. So it's a tetrahedral molecule. So when we need 4 equivalent bonds, 1, 2, 3, 4, that's gonna be a tetrahedral geometry around carbon. That's 109.5. That's going to require sp3 hybridization. That's how, when you mix one s and 3 p orbitals to get an sp3 hybrid orbitals, you're going to get 4 equivalent orbitals. Okay, let's do B. That's ethylene. It's it's a double bond between the carbons, and then you got this kind of geometry. This is going to be the trigonal planar around each of the central carbons. So when you need a 120, let me do this in a different color. When you need 120 degree bond angle, or 3 equivalent bonds, you're going to need to mix 1s with 2 p's. So that's going to create 3 equivalent bonds, 1, 2, and 3. All right, so it's going to be sp2 hybridized for both of these carbons, and then this is our pi bond there. All right, that's going to be from the side-to-side overlap of the p orbitals that is not hybridized. Right, so all the rest of the bonds are sigma bonds, by the way. So, all right, let's do C. Okay, that's acetylene or ethyne. It's a carbon with a triple bond. It's going to be a linear molecule. When you have a linear molecule, that's going to be 180 degrees bond angles. That means you need 2 equivalent electron pairs. So that's going to require sp hybridization. Okay, you're going to mix 1 s orbital with 1 p orbital to get 2 equivalent orbitals, right? And so the remaining 2 bonds are going to be your pi bonds, right? One along the x-axis, one along the y-axis. Okay, those pi bonds are not hybridized, and they're going to form side-to-side overlap. Okay, and let's see, D, C2, N2. Okay, it's another linear molecule. So same thing as that. So the previous one, when you have a linear geometry, you're going to need 180 degrees. So that means you're going to need to mix 1 s orbital with 1 p orbital. For each of these, you're going to get 2, right? There's one of the sp orbitals. There's another one, and there's another one there. Okay, so you're going to need, each carbon is going to have 2 of them. And the remaining, so think of it this way, all single bonds are sigma bonds, and then if you have a double or triple bond, those are going to be your pi bonds. So these are 4 pi bonds there. All the rest are sigma bonds.